Welcome to my web tutorial over pulleys. So if you missed class today, then you're going to need to get a piece of notebook paper and give it the number 63 and write the pulleys notes on it. And you can get the page 62 worksheet from the worksheet page on the website. Remember, I'm going to be reading through these. You pause and write your notes as you need. Pulley's intention can be a little tricky. However, all a pulley does is change the direction of the force. So when we're working these problems, we can make an assumption. So we make three assumptions. So the first one is that the string has no mass. The second assumption is going to be that the tension in the string is the same everywhere. And then there is a third assumption, and the third assumption is that the pulley itself, or the pulleys, are massless and frictionless, so they do not add any forces to the system. Now, this is utopia, of course, but these are the three things that we need to keep in mind and to just assume as we are working our pulley problems. So I want you to read this. I'm going to read it to you, and in your mind, you decide whether you think it's A, B, or C. Two identical rubber bands connect the masses as shown. Mass A is the smaller one. So there's the smaller mass. Mass B is the larger one. Makes sense? The amount of stretch, which also means tension, in each rubber band is greater for, is it rubber band A or rubber band B, or is it the same for both? Remember what you just wrote down, read back over it, and think about this. So what you need to think about is if the two objects weren't connected, they would have different tensions, stretch, because they have different weights. So the information that you need to write on this is what I have underlined here. Now, since they are connected, they are pulling on each other equally. This is Newton's third law, and thus connecting them makes the tension stretch the same for both. Now, tension and stretch here are used back and forth. Now, there are three types of pulley systems. They are the basic pulley. That is what we're working on first, and that's what we learned today. It's this first picture, okay? So we call this Atwood's machine, and that's from the guy who actually invented it. Then we have pulleys on a table, okay? So that's pulleys on the table, and then we have pulleys on an incline, which is our third type. Okay, so make sure you know the three types of pulleys. You will have a quiz this Friday over pulleys. But anytime that you are solving a pulley problem, you are going to go through these six processes or six steps of calculating. First, you need to draw the free body diagram for both objects on the pulley. Second, you find the weight of each object, and remember the weight is Fg, which we always find using the mass times the acceleration of gravity, which is 9.8 meters per second squared. You should most of the time be given the mass. Sometimes you may be given the Fg and asked to find the mass. So always pay close attention. Step 3, make the object that will travel downward M1. You're going to have two masses because you're going to have two objects. One of them you're going to label M1, the other one is M2. It stands for the mass. Step 4, you need to figure out the equation for the net force. So the net force is going to equal the Fg1 minus all the opposing forces. Step 5, solve for acceleration. A equals F net divided by the M total. Note that means The M total means the mass of both objects added together. Step 6, we need to substitute acceleration into the tension equation to solve for tension. So tension is the Fg1 minus the M1. Okay, that's just only one of the masses, and it's the heaviest one, times the acceleration, which is what you just would have calculated up here. Okay, so make sure that you put in your notes this free body diagram over here to the right. I have got the tension shown in the red arrows, and the FG and FG2 are in purple arrows. So those are free body diagrams right there. So off of this particular slide, you're going to need to make sure that in your notes you have the bottom sentence, the last sentence. But when we see these two masses, they are attached to the ends of one cord. So here's one and here's one. The cord, remember, is massless, and the pulley is frictionless. Okay, and again, we call this an Atwood machine. The reason why we label this box, which is the heaviest, M1 or FG1, is because it's traveling down. And all our numbers will be positive since this is the greater one, okay? This is the greater box. You can tell by its size that it's bigger. So the larger mass is going to travel down because it has a heaviness to it, if that makes any sense. However, it can be slowed down by the lighter or the smaller mass. So the acceleration is not going to be 9.8 meters per second squared. It will be something else. So how do we get this formula? Well, we'll need to bring back information that we have done before and have already studied. We know that acceleration can be calculated taking the net force and dividing it by the mass. We get that formula from this formula that we learned a unit ago. Net force equals ma. We just rearranged it, and when we rearrange it, we take the m and get it out of the way, and so we get this. Okay, so here's a formula. And then way before this, the most simple way that we use to find our F net is when, remember, we had a box, and it doesn't matter whether it was the F of A or the F of N, but if we had like 60 newtons here and 50 newtons here, or we could do it this way, F of N, F of G. Let's say this was 50 newtons and F of N was 60 newtons. All we did was subtract these two from one another, whichever side it was. And so we could give it a little formula like this, okay? But even if F of G had been bigger than F of N, we would still subtract. So what we end up doing is marrying these two formulas, this one and this one, and we now substitute in f of g 1 minus f of g2, because f of g2 will always be smaller. The only difference is instead of a box, here we have the pulley system. Okay, this right here was just the box. Now we've got the pulley system. So these guys are going to create a net force with one another. So all we do is we plug in. So we have the M from here, but except it's total. So we had to get the total mass, kilograms of M1 plus M2. So if this is M1, M1, then this is M2. And we add those together because that's the total. And then what we just went over, this, and we said that this is like this situation, very similar, except it's FG1 and FG2, becomes our F net. So it's just another way of writing F net. FG1 minus FG2 is another way of finding the net force. And so you can see that our formula, acceleration formula, says F net, so we can substitute this in for our F net, which is where we get this F of G1 minus F of G2. Now, our last slide said that we have to take our acceleration into account to get the tension, because that's going to create part of this movement in tension. So we got to include the acceleration in our tension formula. So our tension formula then is going to be F of G1 minus the M1. Notice it's the M1 mass. It's the mass of the heaviest box. Okay, times acceleration, which is what we get from there. And that's going to be our tension. So we only use FG1 here, and we subtract out its mass and then the acceleration that we just calculated. So in class, I did this form for you. So let's draw our free body diagram. This is my FG1 because it's the bigger one. It's the one going down, and this is my FG2. So I'm drawing my free body diagram right now. And this is my tension. Okay? So I'm going to do first, I'm going to find my FG1 and then my FG2. And remember, Fg is calculated mass times A. Not A, G, which is 9.8 meters per second squared. My mass is 5 kilograms. And 9.8 meters per second squared, which equals 49 newtons. My Fg2 is 2 kilograms times 9.8 meters per second squared equals 19.6 newtons. I get my F net, remember, by taking my Fg1 minus my Fg2, but I can calculate acceleration and my F net all in one. Make sure when you put this in parentheses, though, when you're putting this in the calculator, that you're using these parentheses, open and close, or else you'll get the wrong number. And then I have to get my total mass. So I'm plugging in. My Fg is 49, Fg1, excuse me. My Fg2 is 19.6, all divided by the total mass. So I have to add 5 and 2, which gives me 7 kilograms. And when you do this, you should get 4.2 meters per second squared. But I'm not done. That's one part. The question asked me to find the acceleration, which I did, and the tension. Remember, tension is Fg1 minus mass 1 times the acceleration that I just calculated. So 49 newtons minus my mass of M1 is 5, not 2 and not 7, but 5, times that, and when I calculate it, I get 28 newtons. And always square your answers. Okay, so there's that. I don't know why I'm erasing, but I am. All right, so try to do problem 2 by yourself. I'm going to put the video on problem 2. In your notes, you're going to need to write what is the acceleration and tension of the blocks, and then draw this pulley system, labeling it the 8 kilograms and the 3 kilograms. So pause the video and do it, and then you can play the video after you've done it, and then you can check it. Okay, so I'm going to move on. So there's your tension, force, and here's your acceleration. And that is the end of the video. Thank you for viewing, and hopefully I'll see you tomorrow.